In this lecture, we're going to learn about string view parameters, and we're going to start by looking at a simple example here. We have a function which is not going to return anything. Its type is void, the return type. The name is say my name, and it is taking in an std string reference as input here. You can see that right here. And we have a definition of that function down here, nothing special right now. And we can set up a simple string, put in Daniel, my name, and tell the function to say my name. If we compile this program, it is going to work and everything is going to be fine. Okay, you might be saying, I have this function, it is working fine. Why don't I pass it a string literal and see what happens? And you might try to call it with Daniel as a string literal like this. And you're going to be surprised to see that the compiler is going to give you a compiler error. Why is this the case? Try to think about this. Okay. In the last lecture, we saw that if a function is taking a non-const reference, it's not going to support implicit conversions. If you try to set up a mechanism that is going to use implicit conversions, you're going to get a compiler error. And this is exactly what we have here. What we are passing to the function is the const char array. Okay, this is what we have here. Daniel here is going to be expanded into a const char array. But we are trying to pass this to a function that is taking in a non-const reference to a string. So the compiler is going to see that it might do an implicit conversion from const char array to std string here. And it is going to notice that our function here is taking a non-const reference. And this is not allowed. The compiler is not allowed to do implicit conversions if the function is taking a non-const reference. That's why we will get this error here. And I really wanted you to be super clear on why this is the case. Okay, now we know about this compiler error. What can we really do to solve it? Well, we can try and make this function take a const reference. And we can change its signature to something like this. It is going to take a const std string reference n. And now, if we call it like we do here, it is going to work. But this is still problematic because if you try to think about how this is going to work, the compiler is going to notice that what you are passing in here, the type for this is different from the type that we have in the signature of the function. And the compiler is going to do what it knows to do. It's going to set up a temporary variable. The temporary variable is going to be of type std string. And what it is going to do, it's going to copy what we had in our string literal character by character. So we are going to store a copy of our string literal in our temporary here. Okay, so this is going to be a copy. Then it is going to pass a reference to this temporary to the function when it is called, and we're going to have our output here. This is all fine, but we don't really like these copies. This is something bad, and we don't like unnecessary copies in our C++ programming. So how do we avoid these copies? That's what we're going to look at. If you really want to avoid those copies, you should pass your parameters as string view parameters. And this is going to solve all the problems we have seen so far. If we set up our function like this, we can call it with a regular string variable like we are doing here. We can call it with a string literal like we do in the second line here. We can even construct a string view type in place and pass it as a parameter. We really have a lot of flexibility in how we can call these functions. And if you really have to pass a string as input to your function, it is recommended to use string views in modern C++. And if you don't know what a string view is, please go back and watch the lecture on them in our chapter on character and string manipulation. I think we covered that. And you're going to really have a good time if you use them as input, if you have to pass a string as an input to your function. Right now, we're going to head over to Visual Studio Code and actually see this in action. Okay, here we are in our working folder. The current project is string view parameters. We're going to grab our template files like we always do. We're going to copy them and put them in the current lecture. And we're going to open this in Visual Studio Code. Let's open folder. We are going to have our main CPP file. Let's clean it up like we always do. And we are going to set up our function here. Let's close the left pane here. I don't really like it to be in the way. We're going to say void, say my name, and it is going to take an std string reference as input. Let's call this name. And we're going to jump in here and say stdcout. And this is going to be our function here. We can head over in our main function and set up an std string type, a variable. And we're going to initialize this with whatever name. Let's say John here. Okay. Once we have this, we can call our function. We're going to say my name, and we're going to pass in some name. Okay. And this is going to work as we expect. Let's try and bring up a terminal so that we can run this. And we're going to build with GCC. The build is going to go through. The build is good. And we can clear and run Rooster, and it is going to say, hello, your name is John. This is what we expect. But what if we want to pass a string literal to this function? We don't want to pass a variable like this. We can comment this variable out, and we want to pass John directly because this is a logical use for a function like this. So we're going to say John here. And at the moment you do that, you're going to see that we have a squiggly line. And the IDE or Visual Studio Code is going to say a reference type of std string cannot be initialized with a value of type const_char array. And this is exactly what we are trying to do here. We are trying to pass a const_char array to a function that is going to take in a non-const reference to a string. And this is disallowed by the compiler. If you remember from a previous lecture where we were talking about implicit conversions with references, this is not allowed. If a function is taking a non-const reference, implicit conversions are not allowed. And if you try to set up a mechanism that is going to use implicit conversions, you're going to get a compiler error. And this is exactly what we are doing here. So the compiler is going to stop us from doing this because this would really cause confusion if, for example, somebody tries to change this string in the body of the function here. Because if you notice here, this is not a const reference. And people are allowed to do whatever they want with this reference and affect the original variable that you pass in here. And remember that if you have an implicit conversion like this, the compiler is going to set up a copy. So it won't really know who is going to own the changes that you do here. Is it the copy or is it the original variable? And we're going to be confused, and the compiler is going to stop us from doing this kind of mess here. And again, if this is not making any sense, please go back to the lecture where we talked about implicit conversions with references. We talked about this problem in detail, and if you go there, you're going to understand that this is not allowed by the compiler. So what option do we have here? In that lecture, we saw that if we are using a const reference, that might work. So let's try and change our function here to take a const reference. You see that now it is working, but it is still going to do an implicit conversion and go through a temporary variable that it is going to pass to this function here. Let's try and compile here and show you that it is going to actually work. Okay, build successful. Can clear and run Rooster, and it is going to say our name. So this is working exactly as we expect, but it is still making a copy. I don't really have a way to prove to you that the compiler is making that copy, but it is making that copy because this is an implicit conversion, because this is a character array that we are passing in. A string literal is going to be expanded into a const_char array. And our function is taking a const reference to std string. So the implicit conversion here is going to cause for a copy of this string here to be created and stored somewhere in memory, and that's going to be a waste. We don't want this copy. So another solution we have is to change this function and make it take an std string view parameter. We can do something like this and say sv, for example, and this is not let's call this name. It's not SV, no problem. And is this going to work? Do we need to include the library for string view? Let's include it. I don't think this is going to hurt. So we're going to say string. And you notice that now this is working. We don't have a squiggly line here. And if we're trying to compile, the build is going to be good. And if we run it, it's going to say, hello, John. Okay, this is the output. And if we revert back to using a simple variable, let's do that. We're going to make it say some name, or we can even comment this out and say it down here so that you have this for reference. So we're going to say my name, and we're going to give it some name. You're going to see that this is going to work. We can use our function here however we want, and this is going to really give us a lot of flexibility. We can clear and run rooster hello John, and we can even construct a string view argument in place and give it a string literal. We can say my name and say std string view and initialize this with a string literal like Samuel, why not? And if we do this and compile this program, it is going to work. It is going to say hello Samuel. Let's do that. We're going to clear and run rooster, and it is saying hello, your name is Samuel. So this is really the flexibility that we get by using std string view as an input if we are trying to pass some string data as input to our function. This is going to avoid unnecessary copies that you might otherwise get if you try to do an implicit conversion from a character array, or a const character array to be exact, to an std string reference. And this is really all we set out to do in this lecture. In closing, I am going to give you my general recommendation. Where possible, always try to use std string view for string input to functions. And otherwise, you should use const references for other types. And if you do things this way, you're going to stand a better chance at avoiding copies in your C++ programs. We are going to stop here in this lecture. In the next one, we're going to learn about implicit conversions from string view to std string. And we're going to see how they work. Go ahead and finish up here and meet me there.